Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal Faris bin Ahmad Suhairi and my metric number is 074430. We are from group 16 and our topic is computer organization and architecture, which is ARM memory management. So next. Okay, now I will explain to all of you about the introduction of our topic. So, ARM memory management is a system used in ARM-based processor to manage and access memory in a computer system. The ARM memory management unit is responsible for translating address of code and data from the virtual view of memory to the physical address in the real system. The translation is carried out by the MMU hardware and is transparent to the application. In addition, the MMU controls such things as memory access permission, memory ordering, and cache policies for each region of memory.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Husni Amir bin Hasbi. My metric number is 074434. Today I will explain about the structure of ARM memory management. The virtual memory system architecture offered by ARM is adaptable and can be customized to the requirement of embedded system designers. The ARM MMU carries out two main tasks. First and foremost, it is in charge of converting code and data address from the virtual view of memory to the real system's physical address. The MMU hardware performs the translation, which is transparent to the application. The MMU further regulates memory access by inspecting the permission, memory ordering, and cache policies for every memory region. Next, in design and architecture, virtual memory address translation. The key feature of such a virtual memory system is address relocation, or the translation of the virtual address issued by the processor to a physical address in main memory. The ARM MMU is responsible for translating address of code and data from the virtual view of memory to the physical address in the real system. Memory access based on either section or page are supported by the ARM MMU. Section in memory management is one level paging scheme. Each section described in the level 1 page table describe the 1 MB block of memory. Two levels of paging scheme are used in paging memory management. Each page table described in the level 1 page table identifies a level 2 page table. Each page descriptor in the level 2 page table identifies a memory page frame and access control bits. Two different page sizes are supported by the ARM paging scheme. Large pages are made up of 64 KB blocks of memory, while small pages are made up of 4 KB blocks. There are 4 subpages on each page. Access control can be expanded to 1 kilobyte and 60 kilobyte subpage within small and large page respectively. Next is access control in design and architecture of ARM memory management. Each table entries API access control bits regulate how a specific process can access a specific area of memory. The section of memory may be marked as read-only, read-write, or no access. The area may also be defined as privileged access only, making it available only the OS and not the application.
My name is Muhammad Amar Rafiq bin Adnan. My metric number is 074431. Today I will explain about design and architecture. First, the instruction set. The instruction set is machine code of a computer is language used to directly program the CPU. Each CPU is designed from the floor as much as support a specific instruction set. An instruction set is a hard and fast if hard-coded operation that the CPU can perform. This operation can be For example, adding numbers together, leaping to a different part of the program, or evaluating the value.
Next is memory management formats. There are three types of ARM memory management formats. The first one is alternative first level descriptor formats, next alternative second level descriptor formats, and the last one is virtual memory address formats. There are four types of ARM memory management parameters. 1. Access permission AP, access permission extension APS. Number 2. Bufferable bits. Number 3. Cacheable bits. And the last one is domain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Abdurrahman bin Wan Fazidin. My matric number is 074433. Now, I will explain about characteristic of ARM memory management. There are two main topics in characteristic of ARM memory management. The first one is DRAM memory support, and the second one is atypical instruction complexity. For the first characteristic of ARM memory management, DRAM memory support. For DRAM memory support, the ARM CPU sends a signal indicating sequential memory locations to the memory controller in order to use rapid DRAM access. For instance, continuous instruction sequence without any acknowledged commands can take advantage of this signal to increase memory bandwidth by about 50%. For the second, atypical instruction complexity. The ARM instruction set is more complicated than IBM 801, SPARC, and MIPS architecture because the CPU was designed to be extremely memory efficient to optimize the memory space bandwidth for loading instructions. Thank you.
Now let's take a look major performance. One of ARM memory management major performance characteristic is its ability to provide memory protection, which ensure that process cannot access memory that they do not have permission to use. The ARM memory management system supports efficient memory allocation and deallocation, as well as efficient page replacement algorithm to ensure that memory resources are used efficiently. Now we take a look advantage of ARM memory management. The first one is affordable to create. The ARM memory management is very expensive since it does not require expensive equipment to manufacture. Other than that, work faster. ARM performs single operation at a time. It has lower latency that ensure quicker response time. And the lastly is low power consumption. EMP processor consume less electricity. They were initially meant to operate at lower power levels. Now we go to disadvantage of ARM memory management. There are few disadvantages of ARM memory management. The first one is x86 is not compatible with ARM and it cannot be utilized with Windows. The second one is it have limit on speed because some processors have speed limitation and this could cause issues. And the last one is instruction must be inserted wisely and it has limited calculation capacity.
Now I will explain for the conclusion. In conclusion, ARM memory management is a essential system that allows ARM-based processor to effectively manage and access memory in a computer system. The system is typically implemented using the Memory Management Unit (MMU), which translates virtual memory address used by the processor into physical memory address. This system allows for memory protection and virtual memory, which allow for larger program and more data to be handled. However, implementing ARM memory management can be complex and may have an impact on system performance. Despite their challenge, this challenge, the use of the MMU and the advanced memory management capabilities provided by processor are vital for building efficient and secure system.